Hello, my name is Amit Sen, and I'm a software engineer under the Technology Services Special Programs team here at Esri. My team and I work to construct software and build technical solutions with the ArcGIS APIs for a variety of different clients and customers. For this presentation, I'll be going over secure coding, or rather approaches to design secure software from the start using a paradigm called domain-driven security. So to reiterate, I am a software engineer, not a security expert. I like to think that I build things, and the way I build it is through constructing software. With the different projects we take on, we have to prioritize different aspects. Our foremost consideration starts with our clients and the stakeholders. Before we build anything, we need to understand the problem or the business needs that we're addressing. The business functionality really is a core of any application that you build. And then you can start considering other attributes such as what's the budget for the project or what the delivery timeline looks like. And from there, you can go ahead and start implementing features and designing the architecture and really just building the product. And the entire time, while we should be thinking about security, we're often focused on delivering the core functionalities first, especially when there might be a tight budget or rapidly approaching deadline. So what I hope to accomplish during this talk is to show you how security doesn't necessarily have to be some feature that's added on at the end, but something that is a design consideration. And with domain-driven security, that's the main idea. A large number of vulnerabilities can be avoided simply by just using good design practices. So I didn't come up with domain-driven security on my own. A lot of other smarter people have had brilliant discussions and conversations that's led to this definition of what domain-driven security is really all about. One of those people is Dan Johnson. We have this quote here: domain-driven security is about taking ideas from domain-driven design and using them as tools to address security concerns, even though the tools were not originally designed specifically for security issues. And it's very true. Domain-driven security is essentially largely influenced by domain-driven design, with an emphasis placed on some of the security aspects that we need to take as we construct software. At the essence of what we're doing is we're still just trying to make code that captures its real-world meaning. Outside of helping you catch security vulnerabilities, domain-driven security and domain-driven design helps you to think critically about what you're developing and the software you're making in relationship to its context in the domain in which you're making it for. To no surprise, I found a relevant XKCD. Reading through it real fast. Premier Election Solutions has blamed Ohio voting machine errors on problems with the machine's McAfee antivirus software. Wait, antivirus software on voting machines? You're doing it wrong. Why? Security is good, right? Of course, but, well, imagine you're at a parent-teacher conference and that teacher reassures you that he always wears a condom while teaching. Strictly speaking, it's better than the alternative. Yet someone is clearly doing their job horribly wrong. And that's another part of why I really like domain-driven security is it forces you to think about the business logic, about the business functionality, and doesn't create any sort of compartmentalization between the business logic, the development, and the security aspects, and really creates a holistic approach that's ubiquitous across stakeholders to developers to security engineers on how to create a good product. Today's presentation isn't long enough for me to go into the theoretical deep dive of what domain-driven security is about. I hope that you do get a decent understanding of some of the ideas behind it, but more importantly, I do want you to have takeaways to where you can start applying some of the best practices in the applications you design today. There were four main topics that I was going to touch base on. 1, mapping out your system with domain models. 2, data validation and the context in which you conduct your data checks. 3, immutability and how it can prevent issues with data integrity and data availability. And lastly, why and how you should be handling failures in your code. We start to define what our system is using domain models. To clarify what our domain is, at its most abstract, it's just stuff in the real world. Our domain model is a defined version of what that stuff is and what's happening with that stuff. We create definitions to what our objects are, what the entities are, so that when we start transforming it into code, our code is just a version of our domain model written in a programming language. When we create our domain models, we want to keep them simple. Reality is actually pretty complex, so when we're trying to transform it or abstract it into these domain models, we only want to make sure that we're getting the parts that are directly relevant to the business logic problem. When we keep our model simple, we get a lot more control over the understanding of what needs to be done, what's relevant, and additionally, strictness. What we mean by strictness is essentially we want to be precise with what we're defining in terms of the ideas, any relationships between objects, as well as what those objects are doing. And lastly, once you've defined the different objects, the different models, and the relationships, you create a ubiquitous language. Essentially, what that means is that now, when you're talking to your stakeholders and vice versa, you're able to communicate what the system is doing in a way that they understand and mitigates any sort of misunderstanding. When you define the terms of the language that you use to communicate, you help really be precise with what aspects of the application are doing what, which is actually a pretty important thing, especially with the work that we do. We're constantly talking to our clients, and often our clients are the domain experts. We're just software engineers. We have to make sure that what we build and the way we communicate is within their understanding of the problem that they have, as well as our understanding of it. And it really is ubiquitous too. Whether or not you're creating that install guide or configuration guide, and even within your code and your database, you want to make sure that you're using the same concepts or rather well-defined domain models so that it's consistent throughout the entire system. For this presentation, we're going to focus on 3 building blocks of domain models. There are a lot of other things that you can consider when you do create a domain model, but for this presentation, we're just going to focus on entities, value objects, and aggregates. At the end of the presentation, I'll also have some resources that you can check out on your own on domain-driven design and learn more about how different domain models can be created. We create our domain models to capture different parts of the real world. We're trying to capture some meaning of something. One way to do that is with the building block of an entity. An entity is essentially anything that has some set of properties or attributes. The one thing that really makes an entity is it has a unique identity, and that identity is used to kind of distinguish it or make it distinct from other entities. So in this example, I have a user. Maybe this is from ArcGIS Online. We have our user who has a name, an email, and the credits allocated to them. Now, over the course of time, the life cycle of this entity, some of these properties or attributes can change. So, for example, over time, maybe the user is using some of those credits, or the age property of that user is incremented to 1 over the course of a year. These entities are a very important part of representing different ideas within our model. But not necessarily everything in the model has a unique identity. Another important building block of domain models is the value object. Now, the main difference between an entity and a value object is that the value object doesn't necessarily have any particular identity to it, but it's defined by its value. Now, it's a little bit different from just saying the value is 5 or something like that. We do want to make sure that our object is representative of something in the real world. So when you look at the diagram that I have, you can see on the left-hand side, we just have the user and all of its associated properties: ID, first name, last name, the credits, and email and phone number. But then when we look at the model on the right, we start to separate all of the different properties into their conceptual wholes. Essentially, we group the contact info together, we group the credits together, and we group the name together because these are all the context in which those properties belong. Another very important part about value objects is that they're immutable. And we'll be going to a little bit of that a little bit later on. Value objects also prompts us to think about the limits of what the values could be. So for example, that phone number property, we have to think about what are the limits of a phone number. We don't want to just have a text box that takes an unlimited amount of characters, ranging from letters to special codes. We only want to have numbers, maybe hyphens or parentheses, and we want to make sure that it's well structured. So value objects prompt us to think about what are the limits on the values themselves. So far, we've seen entities and value objects. You can think of these as the building blocks, but for aggregates, it's a little bit different. An aggregate really isn't any individual part of the model, but a way that we group certain parts of the model together. Aggregates are used to help us identify where different state changes are happening within a certain subset of all the domain objects inside of our model. This grouping lets us treat everything inside of it as essentially one unit. So in this illustration, I have a couple of domain objects. Let's say this is something on ArcGIS Online. You have a GIS with its own ID, and under that GIS, you have a set of groups as well as users. However, typically in most business cases, you aren't going to just have an isolated, ArcGIS Online to store all your data. As much as we'd like that, typically what happens is there's a lot of different business systems that are connected to each other. So when we create aggregates, essentially we're saying that this set of domain objects are related to each other, and the state changes are going to be focused to this particular context. So every aggregate has a root and it has a boundary. So for our example, let's say you were using the ArcGIS Python API, which is a great example of this, is typically the first thing you do is you set what your GIS is by passing in the organization URL and instantiating that GIS. And that is the root of how you access the groups of that GIS. It's how you access the users. It's how you access the content. And we can see that this is kind of the ecosystem that's defined, and maybe it is interacting with other databases outside of ArcGIS Online, but this is kind of the context and the foundation for this set of domain objects. So now that you have an understanding of domain models using entities, value objects, and aggregates, let's get to how we can apply security using that baseline understanding. One of the most important parts of using domain models is it helps you understand validation. In your system, data travels from one component to another, from one context to another. When this data is traveling around, you have to make sure that you can trust it every single time. It's important that when you validate that you don't just do it once. You want to ensure that you're continually doing validation so that no untrusted information is ever used. This is one very important part of how we can avoid different attacks such as cross-site scripting or SQL injection. In your system, which you've now designed using domain models, there's going to be a whole different set of data sources. So for this example, I envisioned, maybe some web application of you have, your HTTP requests, your third-party services, database, and even the user. And if you look at the two blue rectangles on the outside, it shows string and integer. And essentially that's different data that's coming into your application. But you see that yellow boundary that they pass through before they reach your application is the boundary of validation. And when you validate, you want to make sure that you're not just continually using an integer or a string if they have some domain context. So if you see those yellow rectangles, that's essentially the context of what those values are inside of your application. That string is an address and that integer is a time. So when you validate, you have to make sure that that outside data is actually what it's supposed to be. Is that string actually an address? Does that address exist? Is that integer a time? Is it a valid, maybe you only need a certain time frame. Does it fit within that time frame? These are the different ways that you need to validate the data that's traveling throughout your system. When you validate, there's a couple different types of checks it can do against your data. So I split it up into 5 different questions, kind of going from a more broad focus to more specific. So the first 2 are where's it coming from and how big is it? And for an example, let's talk about maybe a geocoder service. So let's say you have latitude and longitude. You send it to that service and you're expecting an address back. One, you want to make sure that when you get that response back, that it is coming from a trustworthy origin. In addition, if you're expecting an address, you also don't want to have, maybe a 1 gigabyte size response. It's probably going to be just a short string. Now that we've looked kind of at the data in a broad aspect, let's look a little bit more specifically at the content of the data. Does it make sense? This focuses a little bit more in depth to the lexical content in terms of, let's look to make sure that our address has characters that would be in an address. So if there's any type of slashes or other special codes in the data we get back from the response, we're going to probably discard that data because we know that most addresses don't look like that. After that, we can see if it looks like other data in our database. This one requires a little bit more of a semantic overview of what these addresses look like, and being able to judge it against that, there's different criteria, but this is probably one important way that we can judge if an address kind of looks like an address versus just our input being string or characters and numbers, but not really being an address. And the last one is it formatted correctly? So typically this is, maybe if we're getting a JSON response or XML response, we want to make sure that the structure of that response is formatted correctly. In the context of our domain model, validation typically occurs within the transfer of data between domain objects. But when you have the data for your domain object, that's when you need to start focusing on immutability, whether or not state will be changing for that particular domain object. And whether or not an object is mutable or immutable really matters in the context of security. With mutable objects, you introduce risk. Every time the state changes, there's a chance that that change might be invalid or potentially will break your application. Immutability helps to prevent that. Problems that immutability helps you to avoid can be categorized either as data integrity or data availability issue. Data integrity is essentially the consistency of that object's data throughout its entire life cycle, whereas data availability is just the assurance that when you make a query or you're trying to access data from a certain object, that it will be at the expected outcome or format that you need it to be. Immutability helps keep your object secure. And earlier, when we were talking about validation, we're talking about the transfer of data between the different objects and making sure that through those relationships that the right data is being checked even before the instantiation of an object. And while those are two very important parts of building secure software, you still got to account for when things go wrong. And that's why you have to handle your failures. When you design a secure system, no matter how secure you might be thinking it is, you do have to account for the anomalies. And there's different ways you can handle these failures. So I listed business exceptions versus technical exceptions. And really what that means is be able to discern the context of what is on the business side and what's on the technical side. For example, let's say we were doing that geocoding again. One, if we got a response back that was invalid lexically, that maybe it had some weird characters in it, that might be an exception more on the technical end. But let's say for that input, we needed the address to be within a certain geographic extent, that would be more so on the business side of being able to handle and understand the context of what that data or what that value is inside of our application. When you design for failure, you're expecting your inputs to fail regardless. Even though you might think you have a secure system, more often than not, it's always better to just have these handlers in there to create a more resilient and responsive application to build a more secure ecosystem. So, through this presentation, I hope you learned a little bit more about what domain-driven security is and some constructs that you can take away to start building more secure applications. We talked about immutability, data validation, and lastly, how to handle failures. And really, this is the start of your domain-driven security journey. Some additional books and Resources that you can go check out are Secure by Design by Dan Johnson, Domain Driven Design by Eric Evans, and Dan Johnson's Dear Junior book. A whole lot of this content really was taken from Secure by Design because there's so much comprehensive information that goes into building secure systems without necessarily having to think about it in a security way that really amplifies the way that you construct and build as a developer.